Good evening, ladies and gentlemen. You're very welcome to our Top Potato webinar, Can the Right Nutrition Help Suppress Tuber Disorders? My name is Eva Ross, Marketing and PR Manager for Yara UK and Ireland, and I'm delighted to be joined by my two colleagues, Mark Tucker, Head of Business Development and Agronomy, and our Area Manager, Tom Decamp, specialising in potatoes. Now, let's hear from Mark and Tom as to whether the right nutrition can help suppress tuber disorders. So, Mark, I'll hand over to you to take it from here.
Great, thanks, Eva. Yes, we've got the next few minutes sort of going through this. So we'll have myself just start with just a bit of background and brief comment on aspects of quality. And the nutrients that are associated with that, and a little bit more of the technicality. And then I'm going to hand over to Tom Decamp, who many of you I'm sure will know, and he'll just run through in a bit more detail around specifics on that, how to manage those nutrients, especially thinking calcium there and tuber quality. So just if we start then and think about it, there's been a very good review fairly recently which really does summarise some of the key aspects that we're thinking about, and a nice diagram that's put up there from that review just highlights some of the quality traits, because when we talk about tuber quality then it means different things to different people at times, because it can be just a quality associated with dry matter or starch content, reducing sugars, but it can also then be quality by way of skin finish or internal condition of the tuber. The Maillard reaction, which is highlighted up there, becomes more prevalent in terms of thinking about acrylamides. So yeah, tuber quality can be sort of many things, but there's one thing that I think does come through, and that the various nutrients that can actually have an impact all of those quality aspects, and you can see highlighted on there some that really do stand out in terms of having that positive effect: calcium, potassium, magnesium. And I'm sure many of you would have picked up on that over the years, that they really are critical when it comes to the quality of the tuber. It shouldn't be forgotten as well that we can have negative impacts with nutrient management, and particularly nitrogen. So if we get that timing of that nitrogen wrong, or we have excess nitrogen in the system, then that can have obviously a negative effect on tuber quality. And there specifically we can think of how it can actually lead to a higher level of acrylamide if we really do get it wrong. So that's something that I'm sure will become more and more part of discussions. So yeah, the three that stand out: calcium, potassium, magnesium. But if we think in terms of what are the common issues that are linked, or what common issues link through to many of those disorders that were just described, in terms of particularly skin finish, internal bruising, internal browning, cracking, brown center, hollow heart, all disorders that have been highlighted, and when it comes to tuber quality. And what is it that sort of links and is a common thread through all of those? Well, that's fairly straightforward, and that's having a very good cell wall and membrane associated in that tuber. And that's the thing, I think, that is what links all of them. And there's just a diagram there where, when we're talking about the cell wall, it is the cell wall being almost the skeleton of the plant cell. They're unique to plant cells, having that. And then you have the cell membrane just on the inner side of that cell wall. And really that cell membrane and cell wall are keeping the rigidity of the tuber and the plant, and also then allowing either water or nutrients or products of the various reactions that are going on within the cell to come in and out of that cell and then be moved around the plant. So really important that we think about how we create a really good quality cell wall and cell membrane. The other side of that we see when it comes to tuber quality, as well as that cell wall, is actually then the cell turgor pressure. That's another or the hydration of the cell. That's another real sort of common theme running through achieving high potato quality. So if we get potatoes that are well hydrated, again not hydrated in excess but well hydrated, then they are less prone to damage. And I'm thinking there the damage that's been cited in literature when it comes to the starch grains. When you've got poor hydrated cells, then that starch grain can act and damage the cell walls, and that's when you can start problems of quality coming in. And again, well hydrated potatoes have been associated with lower levels of black spot. Of course, one of the key nutrients of that is potassium, that we'll come on to in just a minute. But if we overhydrate potatoes, then of course that can be damaging as well. We end up reducing specific gravity and low dry matter, but also we can lead to growth cracks if we're not careful. So yeah, hydration of the cell, another really important aspect of maintaining tuber quality. If we look back now at that, the comments around the cell wall, then it's a very complex structure, and the diagram there just highlights that you've got various layers of pectins and the middle lamella cited there, all very complex structures that make up that cell wall. And that's really the starting point with where some of these nutrients play roles. So calcium, it's an intrinsically involved in pectin formation during that cell wall development. So that is what then really gives the rigidity of the cell, stops it rupturing, and keeps its sort of plastic nature. Sometimes it's described as this sort of egg box type of structure where you've got the calcium linking the various pectins to maintain that structure. The other nutrient that I didn't mention earlier on, but because it's associated with calcium, it's worth a mention now, and there's still quite a bit to be learned about it in terms of where its role sits. But 90% of the boron sits in the cell wall structure of the tubers, and the potatoes. So it clearly is important. Knowing exactly where the importance is a bit of an issue. That's still work to be done on that, but it is associated with, again, pectin development, pectin binding of the primary cell wall, and then that other layer that's there, the middle lamella. So there's a real important element, and we know from boron deficiency symptoms that it shows by way of sort of degraded cells and blackening of cells, so clearly has an important role to play. And then lastly there, potassium on the screen, really it's the osmotic ion, as we would term it, so it's management in water coming in and out of the cell, really where it stands out in all plants, but particularly obviously when it comes to maintaining tuber pressure within the cell. We need a healthy level of potassium so that that cell maintains its structure, its turgidity, and then that's less prone to mechanical damage. So yeah, some real sort of key aspects there associated with those three nutrients, but cell wall structure being really fundamental. I'm going to hand over to Tom now, having just highlighted those nutrients, just to see how we might go about managing them in the most efficient way. So hopefully you're there, Tom, and you can pick up on the story.
Yeah, just sorting connection out, Mark. Just 1 minute. Just bear with me 1 minute. I've got to reconnect. Apologies.
Okay.
Just bear with me.
No problem, Tom. It looks okay from my side anyway.
Yeah, I'm going to carry on in a minute. I've just got to...
Just as Tom's getting connected there, then... Oh, are you back on, Tom?
I am now connected. Yeah, apologies for that. Yeah, thanks, Mark. Yeah, well, I think we're all guilty as agronomists, farmers and growers of thinking NPK, and rightly so, we should get that right. But some of these so-called secondary nutrients, or so-called secondary nutrients, like calcium in particular, are absolutely essential for good, healthy growth of the potato crop. And I'd just like to drill down a little bit further into the role of calcium on the potato crop. Now, we've been using for a number of years now the product calcium nitrate Tropicote, which is a granular form of calcium nitrate on potatoes and other crops as well. And why do we use that? Well, the first thing you have to realise is that calcium is not particularly mobile within the crop. It won't move, translocate downwards through the crop. So foliar calciums, yes, you will get some calcium into the leaf, but it will not move down through and into the tuber where it's really needed. So some of these foliars, yes, they'll hold calcium in that foliage, and yes, you may not divert calcium out of the tubers to enrich those leaves, but if you've not got a good basal level of calcium in the tubers, then that's not going to work anyway. So some of the things that calcium deficiency will affect in the crop. Well, you're going to help with suppressing internal issues such as internal rust spot, internal browning. And essentially what it is, when you get a rapid growth spurt, if those individual cell walls within the tuber are not strong enough and rich with calcium, then as they get rapid expansion, they simply burst, and then this exhibits itself as a necrosis or a browning internally. But also helps with skin finish. We've done quite a bit of trials work, both farm trials and replicated trials work on improvements on skin finish by getting calcium levels right. Calcium also helps alleviate stress, particularly heat stress, wilting, a prolonged dry period. Then calcium can very much help with that. And of course, it's all in nitrate nitrogen form, which is a lot kinder to the crop. It's also instantly available, and we apply it as one simple application of 400 kgs per hectare at tuber initiation to the crop in a split nitrogen program. This is just some illustrations of the sort of deficiency disorders that we'll see. As you can see on the top two there, internal issues, so that browning, cracking, internal browning, internal rust spot. We're trying to achieve, when you slice that tuber in half, we're trying to achieve that nice, clean, shiny sheen inside, and also a good skin finish as well. In the bottom there, you can see bruising. Some of the tests we've done, some of the trials we've done on bruising. I mean, that's a lot to do with handling and a lot of other issues, water management. But we've also found benefits in terms of bruising, whereby we think the calcium has actually strengthened that outer cuticle. So when they're bouncing around on machinery or in store being handled, then this helps reduce individual bruising of the tubers. And the other thing that we found is soft rots in store benefits when the crop goes into store, having it enriched with calcium helps combat these particularly Erwinia soft rot and soft rots in store. So the first thing we have to realise, one of the other things we have to realise is that it's worth remembering that the potato crop actually needs calcium. It needs about 50 kgs of calcium per hectare. And when we get this opportunity to apply it at tuber initiation, it's critical that we get it on them because of this problem with mobility within the plant itself. This is a trial we did some time ago now, but it's a proper replicated trial. It was done on the black land down in the fens in Cambridgeshire. A simple trial that involved ammonium nitrate control, applying nitrogen in the form of ammonium nitrate, and running alongside that, applying calcium nitrate at same timings, but applying the nitrogen in the form of calcium nitrate. And you can see there it's quite dramatic, the reductions in incidence of silver scurf, black scurf, and also we saw benefits on scab as well. I'll come on to scab a bit later, but generally it can really help skin finish on a potato crop. It's not an exact science, and a lot of people are still doing a lot of work on as to why this actually happens, but we think that once again getting this strong calcium enriched outer cuticle allows less of these disorders to affect the skins of potatoes. Another misconception really about the use of calcium and which product to use. Quite a few people say, well, we lime, we put plenty of lime on, or the pH is right. Well, I know you don't want lime for potatoes, but in the previous year you might have lime for something. Well, most lime products are in the form of calcium carbonate, which is relatively insoluble. So you're not actually going to get a lot of available calcium for the crop by applying liming products. And even the gypsum, calcium sulfate, which even the fine gypsums, and we found this out from trying to get calcium into carrot crops for violet root rot. It takes a long time, can take up to a year for actual calcium to come through and into the crop. Well, we need to get in a potato crop, we need to get that calcium into that crop at that critical tube initiation timing. CAN, calcium ammonium nitrate, only 5 or 6% calcium, so you're not going to get too much calcium into the crop with that. And on the far left there, obviously calcium nitrate is highly soluble, both the calcium and the nitrate, being in nitrate form, they're both instantly available when you apply them to the crop. This is the timing, tube initiation. Not always easy to hit it smack on. Obviously, the best way to find it is to have a dig around in the field. Sometimes it looks very different on the top to what it looks underneath. Each individual plant, as you start digging, tube initiation is actually when it starts to hook over and starts to boot up. Well, as I say, each individual plant, some of the tubers will be just beyond it, some won't have reached it, and some will be spot on. So try and get as close to that as you possibly can. And what I always say is, if you're going to miss it because of weather or for some other reason, get on a bit sooner rather than a bit later, and it will sit there for a while and then get picked up when that crop reaches tube initiation. Nitrate nitrogen, as I said before, it's a far kinder way of applying nitrate. All crops, not just potato crops, would prefer nitrogen in nitrate form. With ammonium nitrate type products, it has to go through the nitrification process. It can be slightly acidifying as well, whereas nitrate nitrogen, there's no toxicity, it's quick and efficient, and I say potatoes, like a lot of other crops, they do prefer nitrogen in nitrate form. This one. Yeah, this slide just illustrates really how we get calcium into that tuber. If you look at the red dye, it has to go in through those fine. If you look in the right-hand picture, as you look at the screen, those fine root hairs, it has to enter them, then into the stolon, then into the tuber. You have to get it into that soil mix, that soil solution mix around those root hairs. It won't come down from the leaves. And that slide illustrates it nicely. This is the same thing, basically, just showing you that you have to be in and around that tuber, not as closely as possible. You need to get it to the tuber area, then it actually goes into that aerial shoot and then into the tuber itself. It's picked up by those root hairs. So getting it close to that tuber is quite critical as well. So how do we know that we're achieving what we think we're achieving? Well, one of the best ways to do it is to do testing in the field. We do quite a lot of peel analysis at our lab at Pocklington, just to see what sort of levels we're achieving. The sort of levels of 0.15 and 0.2, that's relatively high in the peel. So that gives us an indication of what it's going to be like in the tuber itself, in the heart of the tuber. It's going to be considerably lower, but it does give us an indication of what's going on further in the tuber, bearing in mind that it is incredibly difficult to get calcium right into the heart of the tuber. That's why we start at tuber initiation, so we can start getting calcium into that developing potato. This is the end game, really, the end result, what we're trying to achieve. A lot of the guys out there that are growing potatoes are into the pre-pack premium market. So what you're trying to achieve is a lovely, clean skin, shiny potato. Slice it in half, it's nice and clean, no internal problems. And if you think about it, for the cost of the product, in terms of per hectare, it's probably going to be £90 to £100 per hectare in terms of an application cost. If you put that alongside your general input costs across a potato crop, PCN, seed costs, machinery, etc., that's a relatively low input cost. And if you've got I know yields vary and across the country and varieties, soil types, etc. But let's say, for example, you're growing a 50 tonne per hectare potato crop, and you're getting another £50 a tonne premium for it going into pre-pack or the premium market. That's £2,500, and for 90 or £100 a tonne input cost as an insurance, then I think I would say that's money well spent. So yeah, thank you very much.
Thanks, Tom. So that just to sort of summarise the last 20 minutes there, then I think it's yeah, clear. We started off there just reflecting on the fact that tuber quality, it's associated very much with poor cell quality and poor cell membranes. So we want to really address that and make sure that we give that tuber every chance of having a really good quality cell wall and membrane. So those disorders that we were talking about there, the key nutrients that we highlighted associated with those disorders, and the fact that you've got a poor cell wall is calcium, boron, and then potassium. So they're the three nutrients that you really must think about and get right into your program. Do focus on nitrate, nitrogen. That's what the potato prefers. But again, as we mentioned, we want to avoid excess of that because that can have negative impact. So getting the timing right, which is sort of early on in the potato's life, as Tom referred to, and getting it on at that tuber initiation timing with that top dressing. And then, of course, Tom mentioned that we're trying to get calcium into the plant. That's the critical bit here. We're wanting to get it in and around into that tuber. And we know, as was described, that the calcium doesn't come down the plant. It doesn't travel downwards. So we've got to get it up from that tuber, the Stolon area. That's where it'll come in and then get into the actual tuber itself. So really do focus on the solubility of the calcium that you're going to be using, because calcium nitrate is clearly the winner when it comes to that. So get that on, get it on, and the timing is critical. So as mentioned, tuber initiation, that's when we're really looking for. So go digging, go looking, get that timing right so that we start to give a nice level of calcium nitrate sitting in and around that Stolon at tuber initiation. Then will influence that final quality. So if you want more information on that, then clearly we've got either direct email to us or go onto the website www.yara.co.uk or the yara.ie website, and that there's further information there on products and information in terms of growing potatoes. So I think that sort of covers us. I'm going to hand back now to Eva as we move towards basis points, but also then a bit of a Q&A session.
That's great. Thanks, Mark, and thanks, Tom. Yeah, we have a basis point with the webinar tonight, so I just have it up on the screen there now at the moment. So PN-99377-1920-K. So I'll just keep that up there on the screen while we go through our Q&A session. We have had a nice few questions in with the registrations, so I'll go through that at the moment, and then in your chat box then feel free then to ask a question then as well. So Mark, first question here on foliar phosphate. What is the best timing for foliar phosphate applications to aid tuber numbers and bulking of tubers?
Very good, thanks, Eva. Yeah, good question. Yeah, I mean, phosphate, we haven't mentioned it so far tonight, primarily because it's not one of the nutrients associated specifically with tuber quality, but clearly it's a vital nutrient, one of the most vital nutrients when it comes to the plant's growth and development. In terms of if we want to influence tuber yield and marketable yield, then with phosphate, then we've got two important things to consider. If we want to go for tuber numbers, then phosphate needs to be early on. So pre-tuber initiation is when we want to be getting phosphate into the crop for tuber numbers. If we're wanting to just drive bulk and achieve high yields, bulk yield, then we want to be then looking at applications post tuber initiation, and that's where you would look to be repeating applications of foliar products such as the Magphos K, which we have put that with blight sprays during that sort of canopy development. So yeah, just the tuber numbers, phosphate early. For bulking, then it's phosphate post tuber initiation into the canopy.
Great, thanks, Mark. And the next question, it's a three-part question. What nutritional advice can you give to reduce the chances of getting powdery scab in seed crops? Will adding calcium or zinc help? And is tissue testing a reliable way of testing nutritional deficiencies in crops, considering the fact that crops give different results when tested at different times of the day? So, Tom, I'll ask you to answer the first part there. What nutritional advice can you give to reduce the chances of getting powdery scab in seed crops?
Yeah, I think if I start with the scab bit, I mean, yes, from where we've used calcium in trials, it has shown reductions and some suppression of scab, but there is no panacea for scab, and it's to do with a lot of factors such as water management, pH, variety, that sort of thing. So I think you have to get everything right to do anything about it. It's a very difficult thing, scab. Calcium will help, nutrition does help. You've got a healthier potato crop there that's going to be less susceptible to scab, but it's getting everything right really to try and combat it. On the tissue analysis is, yeah, that is very important, but what it does, it shows you that moment in time. It shows you the nutrient status of the crop, of the potato crop, when you took the sample. So I mean, what we would recommend is that you do a series, you keep tissue testing through the crop's lifespan, and then you build up a better picture of exactly what's going on, what nutrients are coming through. Right, but you might get through to the end of the lifespan of the crop, the potato crop, and it might be short of something. And what else it will also do is it will validate whether your nutritional program, your fertilizer program is the right one or not. And it should be used in conjunction with soil analysis and not one or the other. So a program of tissue analysis and good soil analysis, and then you should know exactly what the nutrient status of your crop is.
Just to pick up on the zinc question there, comment there, then yes, historically there's been work done on the use of zinc for quality and skin finish control, and that was done some time back now with using zinc sulfate, and they were putting 15 kilograms of zinc sulfate per hectare in at planting to achieve the results that they did by way of skin finish. So, and we know that zinc as a nutrient is a precursor in many of the self-defense mechanisms within the growing plant. So zinc is a critical nutrient when it comes to both growth and the plant's own, if you like, defense mechanism. What we haven't got is a really good data set yet in terms of maybe where we use lower levels of zinc in either foliar treatments that we might put on. There's certainly zinc products that are going on to the tuber, which again I think have been shown to be effective. So yeah, not easy to manage with some of the products available there to get the sheer amounts of zinc that were used in some of the early trials work back in I think it was the 80s and the 90s. But definitely a nutrient to watch for, to perhaps do a bit of your own work with in terms of getting it into the crop to help, again, all part of, if you like, a program of inputs to try and get that best quality you can achieve.
And Mark, another question then, this one relating to phosphorus. What is the role of phosphorus?
I mean, as I mentioned, not specifically for quality there, but phosphorus in all plants and potatoes is really critical because it's very inefficient at actually picking phosphorus up through its root system. It's not a great plant for that. But phosphate is absolutely fundamental to the sort of energy supply within the crop. So that energy that we're soaking up from sunlight is going into the plant and being trapped in chemical energy in the form of the ATP there. That chemical energy is what's used then for all sorts of processes within the plant, whether it's nutrient movement around the plant or whether it's just going into growth and development. So really important in terms of energy within the plant. It also forms very key to a lot of the RNA and DNA in the plant. So phosphorus has numerous roles, but I think the number one is about energy and fueling that plant for growth and development.
Great, thanks, Mark. Question here on nitrogen. Tom, I'll ask you to answer this one. Nitrogen in the seedbed versus top dressing.
Yeah, some people do put all the nitrogen on the seedbed, but we would always recommend, if possible, a split nitrogen program. And usually the majority of the N will go on in the base, so something like 70%, and then we'll do the rest, the second application, hopefully in the form of calcium nitrate at tuber initiation. We'll top up then another 30% of nitrogen to get to total N required for the whatever yield, variety, whatever you're growing that potato crop for. And by having a 70-30 sort of split, you're not getting, as Mark mentioned earlier in his presentation, you're not getting a lot of excessive N on late, which can cause problems within the crop. So yes, split nitrogen program on potatoes if you possibly can.
Just a couple of that have come in here on the chat. One relating to the dry, if we have a dry summer. If we have a dry summer, how will this affect the crop more with quality without irrigation?
Yeah, well,
Mark,
if I just come in there, yeah, obviously, if it's dry, if it's drought, the crop's going to be stressed. So using a calcium product at that time, that can help alleviate that stress, and you hopefully won't cause too many issues to the developing tuber in the ground.
And just to add to that, Tom, that when we've done some years ago, we did some work on potatoes in a particularly dry year, and it was very noticeable how soluble it was, and it didn't actually take much soil moisture at all to get into there and down. So yeah, if in a dry year, very soluble product, so it really does get into soil solution very quickly.
Yeah.
Another question here relating to boron. What would be the best way to get boron into the crop, and what rate? So I think that's kind of relating to either solid or foliar.
Yeah, I mean, shall I just take that one? I mean, Tom, pitch in if there's a comment. But yeah, I mean, one of the ways that we've explored and are exploring more is the product NitraBore. So getting, again, if we want to try and influence cell integrity, then we need it early into that crop's development when the cells are being produced and the cell walls are developing. So a way to achieve that is just we've got the product NitraBore, which has boron in with the calcium nitrate. So there, again, you're putting that on at tuber initiation, you're getting some calcium and boron going into the crop at that crucial time. So that's one way of doing it. Then, and I think that would be the most obvious timing, because again, you really do need to get it into that developing tuber. There's often talk.
Sorry, Mark, I was just going to come in. I think potato growers have always been a little bit scared of boron and boron toxicity in the potato crop, but as you say, I think with NitraBore we can probably get the level of boron, enough to do a good job and get boron into the potato, but not overcook it and cause toxicity problems. So I think we're doing some trials with that this year.
Yes, we are. Yeah, we've got some trial work underway looking at boron and going up to some very high levels actually, just to see what sort of impact we can have. Yeah. So yeah, watch this space on that one.
A couple more questions. One relating to calcium, and I think Tom, you kind of referenced this earlier in your presentation regarding calcium. Would it make a big difference if it is applied as a foliar application?
Yeah, well, I did cover that. Foliar, yes, and there are a lot of. As a company, we have a foliar product, but I'd always advocate using it in the form of calcium nitrate, Tropicote, the granular form, because, as I say, foliar calcium sits on the outer leaves. The story is with foliar is that you'll enrich the leaves with calcium, so calcium won't be diverted from the tubers into those leaves. But I'd far rather know that you're applying a product that will actually deliver calcium to those developing tubers. So I'd always go granular calcium nitrate as opposed to foliar calcium on a potato crop.
Thanks, Tom. And just one of the last questions, Mark, I'll ask you to answer this, and I think it's been pretty much covered already. How close does the phosphorus need to be to the root hairs to be picked up, as it is not mobile in the soil?
Yeah, another good question. I mean, phosphorus, and again, depends on what source of phosphorus you got by way of fertilizer, but typically then the Yaramila products are going to be 70+% water soluble, and that means they're water soluble. So initially, after application, then that phosphorus that's in that fertilizer moves down the profile and gets down to where the tube is starting to grow. What then happens is you start, the phosphate effectively starts to settle out, and that's then, as the question says, it becomes very immobile. One way of overcoming that, of course, is to place the fertilizer, either solid or liquid, the options are there, where you place that fertilizer just below the tuber at planting, so that you're then getting a nice band of phosphate material, which as that tuber then starts to grow, those roots grow and pick up that phosphate. So I think that's firstly that phosphate you put on by way of a fertilizer, if you do some top dressing or in the seed bed, that will be immediately water soluble. So that will then start to move down the profile. As it settles out, then at that point, if you like, it stabilizes and it's not going to move very far at all. You're then relying on the tuber roots growing into that zone of phosphate. But yeah, as I say, one of the ways to overcome that is to do a placement of that fertilizer. It's more efficient, and plenty of work over the years to show the efficiency gains from placement of fertilizer at planting, and that can help us overcome this sort of poor mobility that is associated with phosphorus.
Okay, thanks, Mark. Another question here. Can you say about how much water it takes for Tropicote to be used and how much it takes for the likes of can to get the calcium?
I can answer for, I was going to say I can answer for the Tropicote, but it is, as Mark mentioned as well, it's extremely hygroscopic, so it'll start breaking down straight away. We've seen this on brassica crops, in fact, within literally 24 hours. It'll break down, the calcium and the nitrogen in nitrate form will be available. And Mark will probably concur with this, but a product like CAN, where you're not delivering much calcium anyway, it's going to be a far slower process to get any. Well, certainly there isn't much calcium in it anyway, so you're not going to get much into the crop. But also the nitrogen, getting nitrogen into the crop, is going to be a lot slower as well.
Yeah. And there's the comparison of how many litres of water is required to dissolve. I can't remember the figures. Perhaps you got them, Tom.
I think the figure is with, I can't remember off the top of my head, but it's I think the CAN is probably like 1 litre in 60,000 litres of water it's needed to dissolve 1 kg.
Yeah.
For some of the products, whereas obviously 1 litre will dissolve 1 kg of calcium nitrate, so it is so soluble.
Yeah, huge difference in order of magnitude is different.
Great, thanks Tom, and thanks Mark. We have one final question, and it's a very serious question. Do potatoes make you fat? So I think I might answer that one and give you two gentlemen a bit of a break there. I eat potatoes about 5 days a week, and that brother that I mentioned, my brother Anthony, who picked potatoes with me 30 years ago, he was a national hunt jockey for most of his career, and he used to have to do weights of about 9 stone 7 to 10 stone, and he ate plenty of potatoes. So I would say, from an unscientific point of view and from a Ross point of view, I would say no, potatoes don't make you fat, but they are a great source of carbohydrate if you like long distance running. So yeah, don't be afraid to eat your potatoes. That's what I would say. So but I'm sure there'll be somebody that would disagree with me on social media. But Tom, Mark, thank you very much for your time this evening. Thanks for a great presentation. Just before we finish up there, just to mention, as I always finish off our webinars, we do have our reward program, and for our products there, our Yara Bella Tropicote, our Yara Leva Tropicote, and our Yara Mila Complex, and our Yara Mila Actives, all those products carry points that you can then exchange then for gifts. So just search Yara Rewards in the likes of your Google and that, and it will come up. So yeah, just upload your delivery documents or your invoices, and then you'll be able to exchange the points for
Eva,
gifts.
Eva, I've just found, I got that figure that it's 1 litre to dissolve 1 kilogram of the Tropicote, as Tom said, and then it was 1,000 litres to dissolve 1 kilogram when it comes to CAN. So, yeah, a huge difference there. 1 litre to dissolve 1 kilogram with Tropicote,
Thanks,
1,000 to dissolve the 1 kilo of CAN. So, yeah.
Fantastic. That's great, Mark, and thanks for rooting that out there just to confirm it. So thanks again, Tom and Mark, and thanks for everybody for listening in this evening and for all the great questions. Really appreciate you giving up an hour of your evening. So take care, everybody.